Okay, so in this video we're going to do exercise 5.3, multiply big ints, big integers. So the thing here is that we get two large integers which are represented as an array, right? And we need to just basically multiply them, right? And how we will solve this is we will use basic math operations, so we can just multiply the first number and then the second number, right? So let's do this by hand. So 3 times 7 is 21, and 2 is a carry. 2 times 7 is 14, so it's 16, and 1 carries, and then 8. We add 0, can remove carries, and now we go, oops. And now we will be multiplying 6 with every other number. Okay, so 6 times 3 is 18, carries 1, so 12, 13, and 1 times 6 is 6, plus 1 is 7. And we add those two numbers, so we have 1, we have 14, we have 9 plus 3 is 12, and 8, right? So this is how we will basically be doing with code. Okay, so let's talk about time space complexity for this one. For time, we can say that is n times n. N is the number of elements, let's say, in the first array, and n for the second, right? Okay, and space. For space, we need additional, so it's not just m, but it's roughly m plus m. Yeah, and that's it. Cool. So let's just implement this. So we have a function called multiply with two arguments. So first number and the second number, both are represented again as an array. So first we need to check if any of the numbers are negative. If one of them are negative, then the result will be negative number. If both are negative or both are positive, then the sign will be positive, right? So its sign is negative 1 if, so the either first number or second number is negative. So we will do with XOR operator. So n1, the first number is less than 0, so negative, XOR n2 is less than 0, right? And if this is true, so if both numbers are negative, this is false, it goes to 1, and so on. And now after we're evaluating our sign, we need to normalize the input, so both number needs to be positive, so let's do that. So n1 okay, cool. Great. So, and now we need to have a few variables. So results is initialized to 0, and we'll be adding middle results to this results variable, and zeros. We'll start with, of course, with 0. Cool. So this is the first part, and now all we need to do is just iterate over each number. Of course, in reverse. Cool. here we will have current value. Do we need, and we need to have carry, which is also initialized to 0, and another for loop. Cool. Okay, so inside this for loop, we'll have our multiplication, which is so n1 I times n2 j plus carry. Okay, and we just append the modulo. So m modulo 10. What's excess? What's more than 10? We just add it to the carry, right? Okay. Are we done? I think we're done with this guy. And after we're done with this loop, we can check if carry, or we can say even if carry is greater than 0, just for readability sake, and we just append to the cur. Okay, cool. And now we need to update our results. Add is our helper, and just adds two numbers together, results and cur. We also increment zeros. Like this. And after we're done with this guy, we need to reverse results. We need to also update our sign. And then return results. Yeah. And I think that's it. Let's just quickly implement this in code. So here we're just saving our sign. Next, let's have a results variable and zeros. So we have current value carry, which is 0. And now we will just do the current multiplication, so it's n1 times n2j, oops, plus carry, and then carry is just this guy here. We need to handle carry after we're done with this for loop. We will implement this helper function in a bit. Okay, after we're done with all the for loops, we need to reverse the results. So let's just implement this add function. So we have two numbers. Okay, it's easier to have numbers that are both the same length, right? So let's do that. And both numbers are already reversed, so we just append zeros. This function is also helper. And now what we can do is it doesn't matter which one, we can take A or B, but both A and B are the same length now. So sum is A plus this guy, plus carry. I need carry. Okay. So we will save intermediate values into A. So it's modulo 10, and carry is this guy, right? And after we're done, we just return A. Yeah. Cool. So let's implement this guy. We need to get maximum length from both A and B, and then and 0. We can do the same for B. And I think we're done here. Let's run the tests just to see. Okay. So get an error. Let's look at the code. Okay, so we have sign. This looks good. Let's check A function, so we add zeros. Carry. This looks good. Oh. Maybe this was a problem. No? Oh, yeah. Now we have another thing. So if both basically we need to check if n1 equals to 0, if any of the numbers are 0, we can return just 0. Okay, and all the tests pass. Yeah, this was a little long, but yeah, thanks for watching. Until next time, bye.